we present NeuWigs, a neurodynamic model for volumetric hair capture and animation. This is a joint work between Carnegie Mellon University and the Meta Reality Labs research. Recent advances have shown promising progresses on capturing human with a multi-camera setup. However, as an important part of human appearance, hair is still hard to capture due to its complex geometry, detailed appearance, and non-rigid motion. Additionally, how to bring those captured 3D assets out of those complicated capture systems becomes even harder, like driving them in the daily life scenario. This is mainly due to a lack of full observation of hair instantly. To accommodate those challenges, in this work, we present an end-to-end data-driven pipeline that solves those two problems jointly. Our method can first perform dynamic hair capture that is robust and scalable to various motions spanning over long and discontinuous video captures, while yielding photorealistic rendering results. Additionally, we build a hair dynamic power model based on the capture results that can generate no-drift hair animation without relying on instant hair observations, but rather sparse signals like head motion and gravity direction. Our dynamic hair capture algorithm uses a decoder as a tracker DAT scheme that performs tracking via doing autoencoding. The outputs of the autoencoder will be formed into a compositional volumetric representation, which is composed of a group of volumetric primitives. The first output of the autoencoder, which is the tracked hair point, will determine the pose of each primitives. Besides the tracked hair point, the autoencoder also regresses the hair volume, which will be used as a local radiance field for each primitives. By doing differentiable volumetric remarching, we render such 3D representation into 2D images. To train such an autoencoder, we utilize per-frame observation like photometric clues and geometric clues. Here, we show each tracked primitives in form of colorful volumes on the left and the rendering results on the right. We find that this simple scheme could perform tracking pretty well at a coarse level, but still suffers from some appearance jittering. As a result, our method achieves smooth motion capture with photorealistic appearance after using motion data prior to regulate the flow field. In the second part of our pipeline, we utilize the encoding space learned from the previous stage to train a dynamic model in a fully supervised manner. The dynamic model, named Temporal Transfer Module, is designed to perform hair state transfer conditioned on sparse driving signals like the previous head poses and gravity direction. With such dynamic model, during testing, we can perform hair animation in a recurrent manner without relying on instant hair observations. To impair drifting, we use the autoencoder as a denoiser by doing reprojection in the encoding space. As a result, our method achieves smooth motion capture with photorealistic appearance after using the motion data prior to regulate the flow field. Additionally, our method achieves better hair head disentanglement as a result of explicitly using hair segmentation as a supervision. We show that our method is generalizable to capture different hairstyles and is scalable to various motions. In the second part of the pipeline, we utilize the encoding space learned from the previous stage to train a dynamic model in a fully supervised manner. The dynamic model, named Temporal Transfer Module, is designed to perform hair state transfer conditioned on sparse driving signals like the previous head poses and the gravity direction. With such dynamic model, during testing, we can perform hair animation in a recurrent manner, without relying on instant hair observations. To impair drifting, we use the autoencoder as a denoiser by doing reprojection in the encoding space. We also show that the use of the autoencoder in rollout animation can help reducing the drifting and perform a more stable animation. As a result, our method is capable of performing hair animation on iPhone portrait videos. Thanks for watching. Please refer to our paper for more details and our webpage for more video results.